Okay, so 1.6 absolute value inequalities. Virtually the same concept as yesterday. The only difference is now we have a greater than or a less than sign. When you do the as is and flip equation, there's a little wrinkle. You just flip the inequality. And with these, you have to graph on a number line. Okay? So this sign right here is a less than sign. So I write it like this because I'm abnormal. Proud of it. So I write it with that and at the end because it is an and inequality. And inequalities in general connect, right? Or inequalities in general go out. Not 100% of the time. In this textbook, they're nicer to you. In the previous Algebra 2 textbook we used, they had arrows going the same way, opposite directions, no solution, like all bets were off. They're nice to you in this textbook. So an and inequality should connect. Okay? So we're going to look for, once we graph this thing, the arrows to connect at the end. Method to the madness, we write one equation as is. Second equation, I say flip and switch. So we're going to flip the inequality and switch the sign. Flip and switch. I am going to write that and in the middle of those two so I don't forget. Right? I was the kind of student that would forget stuff like that, and it just makes the math a little bit more challenging in the end. So don't be like me. Be smart. So we have the as-is equation, 3x minus 4, less than or equal to 8. The flip and switch equation, we have 3x minus 4. Flip the inequality from less than or equal to greater than or equal to. Switch the sign from positive 8 to negative 8. So all these, except for the very last problem we're going to do, are just like this. Okay, so two-step linear inequalities. Linear because it's x to the first, two steps because they're two steps. That's what I like to call a duh moment. So we have plus 4, both equations, both sides. Again, to continue to emphasize that, I want you thinking ahead in the math. I want you to look at this problem and think in your head, plus 4 divided by 3. So you know those first two steps before you even begin. Right? Thinking ahead helps you understand the math better. 3x less than or equal to 12. 3x greater than or equal to negative 4. So you'll see in some of these problems you will get fractions. Don't freak out. It's going to be okay. On the left equation and the right equation, we are going to divide 3 on both sides of the inequalities, like that. Then we will get x is less than or equal to 4, and x is greater than or equal to negative 4/3. So it's kind of a pain in the ass to graph negative 4/3, so let's bust out the graphing calculator so we can see what decimal that negative 4/3 is. Before you bust out your graphing calculator, raise your hand if you know what that decimal is already. There should be several of you out there that know what it is. Right? It's going to be bigger than 1 because the numerator is bigger. All that's left is 1/3. If you don't know what 1 divided by 3 is by now, we got some fantastic classes for you over at the K8. Okay? We can teach you those basic fraction kind of stuff. So if we just look in the calculator and we do 4 divided by 3, yes, I left off the negative because I can add it back in the end, we get 1.3. So sometimes when you're graphing, it's easier to think about graphing negative 1.3. So when we graph these, and you'll notice this on these kinds of problems, the one on the right, we graph on the left. The one on the left, we graph on the right. I'll show you what I mean if you didn't get that. So I have negative 1/3, right? It was on the right. Now we're graphing on the left. The 4 is on the left. Now we graph that. on the right. Remember, people, you need to pay attention to whether it's an open or closed stop, because we have more stuff, we have closed stop. The negative 1/3, our arrow goes to the right, so our arrow goes to the right. What is it, an and or an or? It's an and. Good job. I double checked just because I'm paranoid. So with an and inequality, we're anticipating they will connect. It won't always happen, but we anticipate that. At the 4, our arrow goes to the left. I never graph it like that. I just think about it and then connect the dots. So either way works for me. Realize when the inequality is an and, your solution set includes integers, or actually it could be decimals or fractions as well. So any number that's in between negative 1.3 and 4. So and means it has to work for both of the equations. That's why it's only that overlap in between. Okay? So if I were to draw my arrow past the 4 on the right here, no deal. That does not work. Alright, write this one down. We'll do one more and I'll have you practice one on your own. So this is an or inequality because it is great or. So or inequalities in general, the arrows will point out. As I told you in this textbook, they're nice to you. I haven't found one where they go weird ways, but it can happen. So our as is equation is 2x plus 4 greater than or equal to 6. So closed dot, if you're the kind of person that's going to screw up closed or open dot, write closed dot here so you don't screw that up. Second equation, we flip and switch. So our flip equation, we get 2x plus 4. Flip the inequality from greater than or equal to less than or equal to. Switch the sign on the 6 from positive 6 to negative 6. So I can look at this, just challenging the way you guys think, right? I can look at this problem and tell I'm going to get an integer answer. How on earth can I tell that right away? So anybody, if you want to tell me, that's cool, otherwise I'll tell you, it doesn't matter to me. How do you know you're going to get an integer answer? Louder. All the numbers are even. And if you look at the number in front of the x, you're going to divide by 2 at the very end. If all these numbers are even and you're going to divide by 2, you're going to get integer answers. Okay? So good, think ahead, right? It's a little weird to think like that, but it totally works. Subtract 4, both problems, both sides of the inequality. So, on the left side, we get 2x is greater than or equal to 2. On the right side, we get 2x less than or equal to negative 10. Last step, both equations, both sides of the inequalities, we divide by 2. So on the left side, we end up with x is greater than or equal to 1. Remember, we're talking in or inequality. Notice how I read it at least twice every time. You too should do the same. On the right equation, we have x is less than or equal to -5. So you just make the simple little baby number line with the -5 on the left and a +1 on the right. Aren't you so happy I don't make you number your number line? Any teacher that does that is stupid, and you can tell them I said that. Next year, especially if it's Cheryl, go, Evan says you're stupid. Or better yet, if it's Paloma, because I like to insult Paloma. It's fun. So, show me with your hand, open or closed dot. Fixed is closed. I think you know what an open dot is, smart people. Yep, closed dot, excellent. Closed dot on both. Boom, boom. It's an or, so we're thinking errors are going to point out. We're going to double check with the inequalities to make sure that's the case. So the -5 inequality points to the left, so I'm going to make my arrow point to the left. The +1, the arrow points to the right, so I'm going to make my arrow point to the right. What an or inequality means is that -5 works for one equation or the other, just one equation. If I plug in 1, it works for one equation, so or means that it just has to work for one of the two equations. One equation or the other. Alright. Do that one on your own. Give you a couple of minutes. Put your virtual hand up once you're done so I know. And then I will harass people who have not signed up for the Khan Academy thing. Up to 21 out of 24. Some people might be absent, so it's pretty good. If you have yet to do the Khan Academy thing, Schoology homepage, orange folder, click on the link, log in, make your name, not your email. Right, so I try to build in these kind of easy days for you because I know this whole online BS can get overwhelming at times, especially when we cram a whole year of Algebra 2 into a single semester. So appreciate these days. Then tomorrow we've got a nasty little 14, 15 slide lesson and then a quiz on Friday. Remember, when we do quizzes in class, that's all you have to do that day is that quiz. So if you guys want to review ahead of time, that's fine. If you want to just take the quiz, you can just take the quiz. For maybe 4 or 5 more hands, and then I will begin the problem. There we go. All right. So, first of all, this is an or. It's also an open dot. So if you finished, did you pay attention to that? Raise your hand if you did an open dot on your graph. Raise your hand if you did a closed dot on the graph. I know somebody's lying. All right. So, as is equation, flip and switch. As is, we got 5x plus 10. Give me thumbs up. You already did it. Never mind. Hopefully you realize you were going to get integer answers, right, and what we were thinking about before, because each of those 3 numbers is divisible by 5. That's how you know you will get an integer answer. So we have an OR here, flip and switch. We get 5x plus 10 less than, not a 10, 5x plus 10 less than negative 15. So subtract 10, both problems, both sides. On the left equation, we get 5x is greater than 5. On the right equation, we get 5x is less than negative 25. So again, when you're doing things like negative 15 minus 10, think what it is in your head. Visualize you're at negative 15. 0 is way in front of you and you're walking backwards away from 0. And then double check the damn thing in your calculator so you don't screw up. Right? Negative 25, just like that. It's easy to make those quick kind of careless errors. You don't even realize you're doing it. So think in your head, double check in the calc. So we get x is greater than 1. Or x is less than negative 5. So just remember, we do not flip the inequality on that second equation, the equation on the right, because we're dividing by a positive. So it doesn't matter if the numerator is negative. Only if you multiply or divide by a negative do you flip the inequality. If you forgot that rule, write it down again. You've got a greater chance of remembering if you do. Now we graph this little view. Open dots on both. Arrow on the negative 5 points to the left. So we point to the left. On the 1, it goes to the right, so it goes to the right. We have an OR inequality. OR inequalities usually, almost all the time, many times, frequently, do not connect. So that looks right. Take your virtual hand down, please. Raise your real hand if you got that problem right. Excellent. Okay, don't write anything down. Read that problem. I'm going to have you guys tell me about the graph. So again, like we've been trying to predict into the future of what's going to happen, solve this one in your head. Figure out what the graph looks like. Do the arrows connect? Do they go out? What are the x values? We have 2 answers because we have absolute value, things of that nature. So think about it. Think about it. Emily, don't forget to take your little hand raising down unless you have a question. Thank you. All right, somebody unmute and give me some piece of information about the graph. Go for it. Trevor. Can you turn your mic up? Hold on, I'm turning my volume up so I can hear you better. Go for it.
We know it's closed dot.
Closed dot. Closed dot, I couldn't hear the rest. Say the after the closed dot one more time, please.
The first one's 5.
First one's 5. All right, Kaylee, what you got?
It's an OR.
It's an OR because it's greater, right? Closed dot OR, we know one answer is 5. Anything else? Go for it, Delia. Did I say your name right?
Delia.
Delia. Damn it. All right, I'll try.
The other answer is 1.
1, right? So when we switch...
Is less than or equal to 1.
Good, less than or equal to 1, because we switch that 2 from positive to negative, and then we add 3. So negative 2 plus 3 is positive 1, and we flip the inequality. Do the arrows, show me with your hands, do the arrows go like this or like that? You can just keep going like that because it looks funny on my computer screen. Yeah, I like that. Okay, good. So that's all I wanted you to do on that one, right? Just kind of think about it. Don't even solve it. That's it. We're done. All right, look at that little beauty. Write that sucker down. This is the last one you have, and then you got homework. Can you believe it? We are almost done with the lesson. Your class, that's only a half hour. We'll probably be like 35 minutes and then done with the lesson, and you have the rest of the time to do your homework. So if you're missing an assignment, what a great time to get that assignment completed. You can even hang up, go drive to Target, Walmart, or Office Max and buy your graphing calculator if you have not bought your graphing calculator yet. Steal your parents' credit card first, and then go buy the calculator. I never said that. I'll have to delete that from the recording. Alright, so first thing we got to do here is get that absolute value by itself first, right? So we're going to get that thing by itself first. So think in your head what the first two steps are. Think. Minus 9 divided by 3. Good job. So we're going to do that. Minus 9 divided by 3. So we get 3 times absolute value 5x minus 1, less than or equal to 15. Helpful hint, never, we said it before I believe, here it is again, never distribute into the absolute value. Never, ever, ever do that. It's like sacred walls you cannot break down. Okay? So we're going to divide by 3 on both sides, and then we will have the absolute value by itself, and we can do the rest of the problem. So what we have left here is absolute value 5x minus 1, less than or equal to 5. So our as-is equation, are we going to end up with a fraction? Raise your hand if we think we are. Yeah, see? Building that anticipation in you guys, it's so good. So as is, this is a less than, so I'm going to write that big fat and in the middle, so don't forget. I'm kind of slow like that. Switch and flip. Flip and switch, either way. So we get 5x minus 1, less than or equal to 5, and 5x minus 1, greater than or equal to negative 5. So we get fractions all over the place here. It's all good. So we're going to add 1 to both sides. Oh, you know what? I realized I screwed up. Nobody told me. No, I didn't. Never mind, I take it back. Sorry. Had a moment. Lack of sleep. Maggie understands. Math's like 20 points off your IQ. I need all the IQ points I can muster, trust me. Okay, so we got 5x less than or equal to 6. Then over here we got 5x greater than or equal to negative 4. Both equations, both sides, divide by 5. On the left equation, we get x is less than or equal to 6 over 5. And on the right equation, we get x is greater than or equal to negative 4/5. Okay, look at 6 divided by 5. Think about it. Think about it. Think about what that decimal is, 6 divided by 5. Raise your hand if you know. Don't say it. Just raise your hand if you know what 6 divided by 5 is. Do not touch your calculator. I know there are several of you who did. 6 divided by 5 is what, Maggie?
1.5.
1.5. Anybody have a different idea? because you should. What?
One time ago.
It's okay. We're taking a guess, no big deal. Henry, what you got?
It's 1.2, right?
1.2, good. So you think the numerator's bigger. There's one more left, right? 1 divided by 5. You think 1 divided by 10 is 0.1. Most of you know that. If instead of 1 divided by 10, it's 1 divided by 5, that 0.1 doubles to 0.2. That's a crazy way my mind works. If that works for your brain, fantastic. If it doesn't, no big deal. So if I know 1/5 is 0.2, then I know 4/5 is what? Show me with your hands. Point what? 1/5 is 0.2, 4/5 is good. Put them down if your hands are up. You're good, just so people don't cheat. That's why. Show me what 4/5. Yeah, you're good, Amanda. Good job. Amanda did this slick move with her hands going through her hair right there, too. That was good. I like it. I know you didn't do it on purpose, but it was worth pointing out. Yeah, good, Maggie. Put them down. So if 1 divided by 5 is 0.2 and you have 4 of them, it goes from 0.2 to what? Yeah, good, 0.8, right? So just kind of thinking, right? It's a short lesson, so we can spend some time thinking about stuff like that. So I'm going to write 1.2 here. I'm going to write negative 0.8 over here, because I find it easier to graph decimals than fractions. So negative 0.8. Show me your open or close stop, quick. Nice. All right, close stop. 1.2 over here, greater than negative 0.8. It's an and, so they should connect. I had a little paranoid moment there. I was like, oh God, they're not going to connect. You've all had those moments, I know you have. All of a sudden the math problem goes horribly wrong, you know what I mean? Been there? I have. They connect. La la la, connect the dots, as I like to say. Alright, so that's it. Absolute value equations and inequalities. So you have a quiz on Friday. We do 1.2 or 2.1. That was a dyslexic moment. That was fun. 2.1 tomorrow. Okay? Your quiz is going to be at least 6 questions. I haven't made it up yet, so I don't know how long it's going to be perfectly honest. I will probably make it up today. What I want you to think about, right, I'm trying to build in that anticipation for you as an Algebra 2 student so that you can use those skills in my class and others. I want you to try to figure out the kinds of questions I'm going to put on your quiz. How on earth would you figure that out, you might ask? Well, what I would do, if I were in my own class, I would look at my quiz work from the previous quiz. I would take like maybe 3 minutes, look through the notes, go, there's that problem. Oh, there's that problem. Oh, look, you wrote a helpful hint next to that problem. So maybe if you write the helpful hint, that's going to be one on there. So just kind of think about things. Tell me what my tells are. I don't even know. Generally, I'm very transparent. And I'm like, this problem is going to be on the quiz. So take a look at your quiz work from the previous quiz. Take a quick look at the notes and try to anticipate what's going to be on the quiz. You do that because it makes your life easier. Okay? Life being easier is always a good thing. Your homework is right here. Just 5 problems on the left. That's it. I'll move that up. Oh, actually first. So the stuff on the right over here is from a previous year. So you don't have to worry about that. You're only doing those 5 problems. Okay? That's it. Bust a move, get after it. If you haven't joined Khan Academy, please do so. This homework should fit on one page. If it doesn't, please take pics, submit them in a single file, right? One file. Okay, enjoy your quick and easy lesson. You can always turn your cameras off during work time. Do not leave, however, until you, number 1, say goodbye, and number 2, have submitted your homework. So as soon as your homework is submitted and you say goodbye, you may peace out. I will stop the recording now. Look at that, I remembered that part.